contaminants. I would like to introduce Jean-Philippe here of Dundee Technologies. Jean-Philippe, please introduce yourself, your business, your role, and what you guys do.
Thank you very much, Jorge and everyone. So my name is Jean-Philippe Mai. I'm the President and CEO of Dundee Sustainable Technologies. We are a Canadian company based in Eastern Canada, a footprint in Montreal and in Thetford Mines, Quebec. Essentially, we are novel metallurgical process provider. So we've been very active in the metallurgical field for close to 15 years now, where we've really focused on the development and now commercialization of novel metallurgical processes for the recovery of precious metal, notably gold. Our process uses sodium hypochlorite, so it's a complete alternative to, and a real alternative to cyanide. And we also work very actively on arsenic material. So we have our glass lock process, which is for the removal and stabilization using vitrification of arsenical material coming from the mining industry. So the company's been focused on this for 15 years now. So we were able to develop our processes and then bring them to the pilot scale, and then we also brought them to the industrial demonstration scale, and now we're actively moving on for on-site operations. So it's been quite a journey, lots of work, lots of data, lots of good things have happened for Dundee Sustainable Technologies over the past 15 years.
I love it. I love it. So when people hear novel metallurgical processes, what is the problem specifically in mining that we're trying to solve with the that traditional methods are struggling with?
It's not so much problems that I refer to them maybe more as challenges, right? Because every metallurgy is custom, no two projects are the same. So different projects have different challenges, so perhaps require different tools. Our industry has been challenged over the last decades on two main segments. First is environmental. I think there's been a big push, a big pressure that's been applied on the industry to improve its environmental practices, whether it's through the restriction or prohibition of the use of cyanide in certain jurisdiction, which then forces companies or project developer to look at alternatives. And the other big segment is from a metallurgical challenges. So a lot of the ores that are being developed and mined have transitioned more from an oxide to a sulfide layer, are more challenging and more refractory to conventional approaches. So in terms of opportunity and what the industry needed was really to have alternative or adapted or new metallurgical processes which can cater and respond to these challenges, right?
Absolutely. And in terms of how to benefit these operators, is this more from a sustainability standpoint? Is there a larger return on investment? What exactly are we improving in the processes of the traditional methods?
What we're offering is a new tool, a new approach, which we always base our decisions and our designs based on increasing efficiency. Our gold process uses sodium hypochlorite, hypobromite in an ambient temperature and pressure conditions. So it's not something that is operating in challenging conditions that requires exotic metals. So it's very accessible. We use a lot of plastic, PVCs, FRPs, rubber lining, but mostly the chemistry, the efficiency and the kinetics of the chemistry allows us to solubilize gold very rapidly. So our contact time is usually about 1 hour, 2 hours at most. So there's a lot of benefits with utilizing efficient kinetics and efficient chemistry to rapidly put gold into solution. Again, it allows for smaller footprint, equal throughput. And then after that, our approach uses halogen. So what's important for us is to regenerate our solution. So as opposed to having an open loop process where we allow for the region to decompose, we regenerate our sodium hypochlorite, hypobromite using an electrolysis cell. So it allows us to operate in a fully closed loop and to have only solid tailings residue as exiting the process. So that's key because that's another portion that has been challenging for our industry is the necessity or ability or possibility of building some of these retainment dams to contain some of the effluent ponds. that the gold mining has been utilizing for years. So what we're doing is by having a process which allows in a fully closed loop, we're able to generate inert and stable solid tailings as the only product exiting the process. Right?
How do we do waste management? How are we managing these chemicals and waste management in the mining operations?
Specifically for Clever, what we do is we regenerate our regions. So we use sodium hypochlorite, a dilute concentration of sodium hypochlorite, which is nothing else than household bleach, like we all have in at home, except in a dilute concentration. Typically, your household bleach will be over 10% in concentration. We use 1 to 2%. And so it's a diluted version of your household bleach. Again, as I mentioned, we operate at ambient temperature, ambient pressure. We use an electrolysis cell to regenerate and to generate our sodium hypochlorite. So these electrolysis cell, it's a known unit. The only thing is that we use them off spec. So we use them with no membrane and to regenerate sodium hypochlorite and hypobromite, which allows us to be a lot more tolerant because we work in the mineral industry and mineral solutions. So there's a lot more impurities in terms of base metals traveling around with this solution. So using these cell and known units for our needs allows us to close the loop and to be very minimal in terms of our waste and our residues, which are essentially the gangue material and the solid material after we've remove and solubilize the precious metal from them.
As we know, the mining industry normally faces skepticism with new technologies or new processes. Has there been any challenges in getting the industry comfortable with adopting something different? Where have you seen the most openness?
Yes, the industry is been known to be somewhat conservative, but also it speaks on individuals, right? I think we all find comfort and refuge in what we know, what we understand. So that's why for us, we're definitely not a black box. So we're very open. We really believe that adoption goes through understanding. So you need to be open and you need to be clear on how the process operates, how it works, so that people can see it, can understand it. And when you understand how processes work, then it's much easier to adopt and to take enlightened decisions on what is the best approach for the treatment of a given ore. So this has really been our approach. And again, our novelty is on the chemistry. So there's no novel pieces of equipment that we utilize. This all the equipment that we use is equipment that's been used already in the industry. So you walk in our plant facility, nothing will feel unfamiliar, you know. So we have, of course, agitated reactors, some pumps, some liquid solid separation in terms of filters, Panvis Bell filters. Either we can use
Yeah,
counter-current decanters. Again, and the electrolysis cell unit is a standard unit. So nothing here
nothing out of this world,
is new in terms of equipment, right? It's all on the application, right?
When one visits your website, they get immersed in the ecosystem of your processes, and you're trying to educate exactly what it is that you're providing. What exactly has been working for you guys? Who are your typical customers? Where do they come from?
We really started with the development and operation of our gold process, our clever process. And of course, when you're developing this new gold process, people send you their worst material. So we worked with a lot of refractory gold ores, where very often that refractory portion comes with the encapsulation of the gold particles within a sulfide minerals. And very often it's an arsenic bearing sulfide mineral. So
Mhm.
we worked with a lot with arsenic-rich gold ores, and this is what drove us to develop our glass lock process, which is essentially once you decompose that arsenic sulfide compound, we're left with an arsenic product which needed to be stabilized. And we weren't quite impressed with what the industry has been doing with arsenical waste. So this is what drove us to develop glass lock, which is a stabilization of arsenic using vitrification. So the two process, Clever and Glasslock, can operate together, but they can operate separately when you have an arsenic residue, an arsenic waste, or an arsenic bearing sulfide concentrate that needs to be de-arsenified And for the arsenic to be stabilized, we apply glass stock. So the arsenic has been a big driver because of the needs. There's increasing amounts of arsenic concentration within the ores being mined, whether it's precious metal or base metals. And in terms of companies, it's anywhere from junior developers that are wanting to find a path for the processing of the ores that they are developing, all the way up to the mid tiers, to the major miners that have operations that require either an arsenic stabilization or mitigation circuit, or are looking at improving their recoveries through utilizing different chemistries. So we work really at the broad end here of the spectrum. So anywhere from junior developers all the way to the major miners.
Is there a requirement to work with you guys? Can someone in exploration, like still doing core sampling, like work with you guys, or is this more for actual operations?
Like anywhere from the junior explorer, I think it's important to
Junior.
align processing and metallurgy with resource development. So that way
Yes,
you
absolutely.
have the information, you have the data, and you have the vision as to how you're going to process this material. It's important and essential on any developer going to a PEA that it needs a metallurgical flow sheet definition. So I think incorporating metallurgy early on in the development of any project is key. So we work with juniors, sending us core sample, and then we do characterization, we do flow sheet development. There's really no requirements apart from the desire to work on a flow sheet which is efficient for metal recovery and the handling of contaminants that can travel the ores.
How are we beginning these conversations with potential prospects? What is working for you guys in terms of marketing or client acquisition?
We've been in the industry for quite some time, so now I think people are starting to recognize and to know the offer and what Dundee Technologies has been developing and what we're offering. So either we reach out to people or people reach out to us, and right away we dig into the discussion of what is the problematic, what is the ore, what are the intention, what are the objectives. And very rapidly we go into doing some preliminary test work because we're not asking anyone to have blind faith in what we do. We like to speak with data. We need to do test work, demonstrate the amenability of the process, the efficiency, get people to understand how the processes apply on their own material. Like any process, we start optimizing and then you start doing some preliminary engineering, some mass water energy balances, some equipment sizing, and some costing so that people can take enlightened decision based on optimized data and to have this engineering design or preliminary flow sheet. So to do some trade-offs because we need to do more trade-offs, right? It's very unfortunate that today, if you're a junior gold explorer and you want to test the recovery of a gold ore, you need to send it to a commercial lab, and all that they will offer is cyanidation bottle roll. There's no alternative being offered in those commercial labs. So if you want to do this, you need to reach out to specialty and dedicated companies like Dundee Technologies so that you can do some trade-off. Here's the cyanidation route, here's the achievable recoveries, but here is the option with Clever. People need to take control and responsibility of their flow sheet and do the trade-off, allow for proper decision making and look at what is the overall impact and benefits of having an efficient extraction process that is a shorter contact time, smaller footprint, only produces solid inert tailings. What is the benefit of removing arsenic and stabilizing it efficiently and not having to send it to a tailing storage facility for eternity, right? So there's
Oh yeah.
there's a lot of decisions, and we're just here as a tool to allow industry to do the test work and to do the trade-offs and to take proper decisions for their projects going forward.
That's something that we're notorious for. We're notorious for just thinking about the short term. How can we get this ore processed the more quickly as possible, getting more investors in as fast as possible, and sometimes we forget about the long run, about the
Mhm.
long-term effects of manual processes or inefficiencies. Allow me to clarify something with you. This process of onboarding with your team, are you establishing facilities near the mining operations, or are they sending it to you? Are you building facilities at the mining
Yeah, well,
operations?
it depends. Really, the objective and the right approach is to build on site at the project, right? So we're
Oh yeah.
not, although we have capacity to treat concentrate in the Thetford mines plant. The objective is not to be a toll processor. We're really developing, designing for on-site. That's really the approach here. But all the test work, the development, the engineering can be done at our facility, but the design is for on-site operation.
Any particular regions that you're looking to expand into or that you're working with outside of Montreal and outside of Canada?
Just this year, we've worked on projects in Thailand and Malaysia, Australia, India. Africa is a big segment, South America. Mining industry is global. So whether you are developing a sulfide or an oxide gold deposit in Asia or Africa, an arsenopyrite or energite, tenantite copper concentrate in South America, we can assist, we can work with this, and there's really no boundaries for us. It's all project focused.
Are there any upcoming developments or new developments that Dundee's working on that you can talk about at a high level?
The pathway to commercialization and implementing our processes is, as I said, we do the initial test work program engineering and then bring it up to the detail engineering for implementation. So I think we've been working on a lot of projects over the years, and some of them are coming now to a point where we're about to move on the construction on site. Again, we work with dedicated mining companies, so I'll let them do their own public announcement, but we're definitely moving and growing in terms of projects and leading up to on-site implementation. So I think over the years, we're able to establish ourselves as a credible process, credible company that really do provide an alternative and efficient processes for companies to do the test work, engage with us. So I think that this is something that's been growing and we want to see continue to grow over the next few years.
You're looking to be more present on site, to have more of these on site facilities. What have been some challenges in implementing this on site construction? Is it more of like the logistics of like delivering the parts or like the legal permits? What has been some challenges for that?
No, it's time. The mining industry is a capital intensive industry. It's a time intensive and long. It takes time to bring a new mine into production, to build a new process plant, or to build expansions within existing mine or existing base metal smelters. The time delays or the time needed to do such things are linked with with yes, in environmental, operational permits, capital allocation, priorities, dealing with some of these large companies that operate in a timeline and decision making that translates into somewhat long delays for when you would compare with other industry, whether you're comparing with the tech industry, it's something, things seem to move a bit quicker than in an industry like the mining industry. So time is challenging. I think that's why as an industry we should all be proactive, serious on doing the trade-offs, and ultimately not be afraid to take decisions for the greater good of the project, right? So bet on efficient processes, be proactive at implementing novel approaches, not be afraid of risking, but going for the reward. I think collectively we all need to be involved and to be part of this turn of the industry of what will be the mining industry 2.0.
It takes a lot of time, and it really all depends on so many different factors. You could get millions of dollars of investment from different investors to launch your mine, but you could still take up to, I mean, some operations are still doing exploration for 10 years, you know? So, in terms of technology and in terms of how in time is being a challenge in this industry, how do you see certain technologies, like, for example, artificial intelligence, assisting in making these challenges a bit easier to overcome?
I'm not an expert in AI. I think this is definitely something that we should all educate ourselves on. I'm curious about it. I'm curious as to how can AI be implemented in every little segment of our operations and what we do. And I think it does. We live in a digital world where there's so much data that even within our own servers, sometimes we're struggling to find our own files. So I think AI can definitely be a tool and should be looked at, implemented at every step of our processes because it's a tool which again will provide efficiency in terms of operations. I'm definitely embracing it when it comes to the automation, the instrumentation of all of our process and all of our systems. I think a lot of our suppliers, manufacturers, equipment suppliers, they are the one also integrating that so that all of our system can work more efficiently. What we do at Dundee Technologies, it's more on the fundamental processes. So on the fundamental chemistry and approach as to how you will treat or handle a particular ore body. So I think once we settle on the fundamental approach and then incorporate the new technologies, I think that can only be beneficial in terms of the overall operation of the project, right? Whether it's new processes or existing processes, I think these will overlay on top of the fundamentals, right?
Absolutely. And at the end of the day, we all have the same vision, being as
Mm,
efficient as possible, sustainable, and return on investment. Like we're investing millions of dollars into these mines, hundreds of thousands of dollars to drill for the core samples. We're drilling rocks for what?
mm,
For the most maximum outcome in the most sustainable way possible in
mm.
compliant to social and governance standards. So I love it. From your perspective, you see as the artificial intelligence potentially assisting in these operations from a data standpoint, more specifically automation of this like data workflows. Is that what you're saying?
I think so. Ultimately, what decisions that we take as professionals as operators, I think can be programmed for AI eventually, right? And if not, it's probably already in place. So again, it's not my expertise, but I think this is the natural development and natural evolution of how AI will be integrated in our workflows and our decision making. Right?
If someone wanted to learn more about Dundee Technologies, if someone wanted to reach out to you, or how could one get into contact with your team?
We're pretty out there, dundeetechnologies.com. So that's our website where there's some contact details and info queries where people can easily send us an email, get in contact with us. So people can give us a phone call, send us an email. You can find us on LinkedIn, Dundee Sustainable Technology. You can find myself on LinkedIn, and I'd be happy to have this intro conversation with anyone and again get this dialogue going. Let's talk about the project, let's talk about the fit and the possibility with our processes and yeah, we'd be happy to get in contact or to have a discussion with anyone interested in exploring how our process can benefit the project.
Of course. Go ahead and leave the website, the contact email, your LinkedIn in the comments below so that our followers can take a gander. So I want to go ahead and take a moment, and I wanted to thank you, Jean-Philippe, for hopping on this call with me. It's an absolute pleasure to speak with you. Love to have you all back on here again. And thank you so much for your time.
Well, thank you, Jorge. It's been my pleasure. Thanks for having me.
Of course, and thank you to our audience. Please, I'll see you next week. Have a nice day. Take care.